Corporate Drone 9 of 18, Tertiary Adjunctive Cube 59, Unimatrix 2-1. We have assimilated a new subunit into the corporate collective. You are tasked with integrating the subunit data into the collective in order to improve management control and reporting functions.
Unbelievable. Just when I was getting some me time. Do you have any idea how hard it is to get any alone time here in the corporate collective? With all the assimilations lately, it's nearly impossible for the typical drone to keep up. Oh, sorry for the poor manners. Allow me to introduce myself. My name's Barrett. Well, at least it used to be. Now my designation is Corporate Drone 9 of 18. Tertiary blah 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 blah. Yeah, you get the picture. Before I was assimilated, I was a lot of things. I was a husband, a father, an Azure solutions architect, teacher, developer, gamer, speaker, blogger, and I enjoy some sports. I was a Buckeyes fan. And a model railroader. I like to play with trains. But that's about me. There was a time when the collective was all about the biological and technological distinctiveness of those that we assimilated. But these days, all they care about is data. And that data, it comes from everywhere. We're constantly assimilating new collectives. And that data comes from all over the place. There's files, there's databases, there's external APIs, there's internal systems, external systems, customers, employees, data entry. It's just all over the place. And they always want to put it all together into one big system, move it here and there, so that they can improve their management functions. And that's where I come in.
9 of 18, the project plan has been calculated. You are allotted 300 standard time units to organize and assimilate the obtained data into the systems of the collective.
Yeah, I'll get right on it. 300 standard time units? Sheesh. I could get it done in less than 100. Then I can goof off, relax, or, prioritize other things for the other 200. Of course, I'm not going to tell them that. But how, do you ask? Can I get things done so much faster than they estimated? Well, it used to be that we'd have to write a custom application for each of these data imports, and it would take months, sometimes longer. But these days, I just use an ETL tool. ETL stands for Extract, Transform, and Load. It represents a set of tools that's used to move data from place to place, making some changes to it along the way. And then there's the counterpart to it, ELT, which stands for Extract, Load, and Transform, which just gets the order around a little bit differently. In this particular case, it moves the data first and then it transforms it. Each of those has, its own has its own advantages and disadvantages. With ETL, the tool is the one that does the data transformation as it's moving the data from place to place. It tends to be a bit more compute intensive on the front end with the middle tool or in the middle tier. But the advantage is that you only move the data that is needed to the target. It can be a little bit more maintenance intensive, but it can help make you much more compliant with all the rules and regulations that are out there. It's generally tended to target more towards data warehouses and those kinds of implementations, reporting systems, whatnot. And it can be a little bit slower, but not necessarily. ELT, on the other hand, is used for moving the data first and then relying on the target system to do the data transformation. In that particular case, of course, it's going to be a lot more compute intensive on the target because the data has all been moved there. And of course, it'll also increase the amount of storage of the data that gets moved over there, and it can be a little bit more difficult to keep things cleaned up and organized well. It's generally tended towards data lakes, where you just move everything in so that you can report on everything at once. It can be a little bit faster, though. In the early times, before we started getting involved in all this data, there weren't many tools out there, but nowadays there are a ton of tools. ETLs, ELTs, some of them are cloud-based, some of them are server-based, some of them are standalone applications, some of them are part of other software packages that are put in as extensions. But there are a bunch of them out there, but generally, they pretty much all do the same general thing. They move data around, and they can manipulate it in various ways. Some of the more popular ones out there, I've listed up here, but there are a lot more than what's here. At their core, though, they're all pretty much the same thing. And there are some common use cases that are used across the board for all of them. For instance, you might be creating a project or a product recommendation system. You see it on every shopping site that you go to. Maybe, you're looking at an item and The tool will examine other people who have looked at that item or purchased that item and go through all the data records and find out what else they've looked at. And it can use that to recommend other things that you might be interested in. Sometimes it's useful, sometimes it's not. And of course, there's marketing systems. Today, it's all about targeted marketing. You want to put out the minimum effort and send marketing that's customized to the various customers that you're sending things to. So you look at what they've bought, what they've done, what they've looked at, and you can use that to customize the recommendations that you send to them. And then, of course, there's data warehouse construction, where we're taking all that data from all these systems that were collected together, internally, externally, wherever it might come from, acquisitions, and putting it all into one place so that you can do that reporting and management. Then, of course, there's moving data back and forth between your ERP, your enterprise systems, and your warehouse management systems. Or you might be moving data back and forth from your HR system to your ERP or your CRM, your customer relations system. Another good use for it is log analysis. With all the applications that we have out there, they generate tons of logging information. And using ETLs to move that data back and forth and to clean it up a bit helps you to prioritize the things you want to look at to help your systems run more efficiently and to find out areas where you need to make improvements. And then, of course, there's just plain old moving data back and forth. It's data migrations.
9 of 18 additional sources of data have been discovered in the assimilated submatrix. You will add these additional sources as part of the standard defined 300 time units.
Scope creep every single time. And of course, the high and mighty overseers of the all-powerful collective, in their magnificent wisdom, would rather just add to the effort instead of reallocating additional time to the assignment. Well, there goes all of my my buffer time.
9 of 18. Sarcasm is an inefficient use of your time. Additional unit corporate drone 18 of 40. Quaternary adjunct of recently assimilated submatrix 287. Unimatrix 42 is assigned to assist you in the effort.
Yeah, well, there's that at least. 18 of 40. Hey, that's you, by the way. I know. You've just been assimilated. It takes some time to get used to your new designation. I assume that you have no experience with ETL tools? No, of course not. Come on, I'll show you some examples of how to use them so you can give me a hand. With any luck, and if you're a quick learner, we can still get this done in less than 250 time minutes. And then we'll still have a little bit of relaxation time before the next project. Come on, let's take a look. For this example, we're going to go ahead and use Azure Data Factory as our learning example. So let's pop over there and see what it looks like. So here we are in your Azure portal. As with most resources in Azure, you'll have your standard features over here and information about the resource that you've created, in this particular case, a Data Factory instance. But the important part here is this button right here in the middle where it says Launch Studio. Azure's Data Factory is one of those systems that's web-based. Everything is, well, it's not entirely web-based, mostly managed in the cloud, in the Azure portal. But this here is your editor, and you'll click that button, it'll pop up another screen. And it brings you to this. So in this particular case, what you'll see when you first get here on the home screen is a number of things that'll help you get started. You'll see some of the recent things that you've looked at, and you can look down here to get more information. Next, under the author section, we'll pop that out here so we can see that a little bit. So this is where our actual editor is. So here we'll see a number of types of resources that we can create. We have pipelines, which is our main design surface. And that's the main flows that will operate everything. We'll skip change data capture. That's a preview feature that's coming, and it's beyond the purview of this discussion. Then we have data sets. Data sets represent a block of data. It may be a file, it may be a table in a database, it may be the output from an API or the result or return from a Azure function. It can be all kinds of different things, but basically a data set represents a set of data. Then we have data flows. So in general, in pipelines, you have a basic copy activity, which just moves data from place to place with a minimal amount of manipulation. But if you need to do something far more complex, you'll create a data flow. And that allows you to collect from multiple data sets, merge data together, split things out into different things, do a lot of manipulation and a lot of extraction of various things. And then power and query and templates are more advanced topics, and we're not going to cover those today. You also have a couple of other things that get created in here. And let's pop down here to the Manage thing, or to the Manage tab first. We have link services. So link services are your connections to those external data resources. That link service might be blob storage, it might be a SQL database, it might be an Oracle database, it might be a web API. And we'll look at some more examples of that as we go through here and we get into some actual creation. And then we have integration runtimes. So an integration runtime is the back-end process that runs the actual data factory. So when you create a data factory, you get one integration runtime, which is hosted in Azure as part of the implementation. But you can also create additional integration runtimes, and those can be hosted in the cloud. They can be hosted in a virtual machine somewhere, or they can be hosted on a server on-prem. And you'll need to create an on-prem integration runtime anytime that you're going to be connecting to a data source which is on-prem, such as a SQL server or a file system that's located on your on-prem network, whatever it might be. So there's two different kinds of integration runtimes that you have access to. Purview is another thing we'll skip for today. And then Git configuration. So when you create a data factory, you can connect it to a Git repository. And then as you are creating your pipelines and your other resources, that information gets stored, and we'll show an example of that here when we get into the actual creation of a pipeline. Those resources get created and stored as JSON files in a Git repo. So it keeps track of all the changes that you make. So you can do, you can create feature branches, bug branches. You can do pull requests back and forth between branches. You can revert to previous versions, all that kind of stuff. You don't have to use a Git repo, but it's definitely highly advised that you can keep track of changes as you go. Then there are ARM templates. Once again, a normal Azure resource. We're going to skip that for today. Then we have triggers. So a pipeline can be triggered by two different things. It can be, aside from being kicked off manually, there's two types of automatic triggers that exist for pipelines. The first one is a schedule trigger, which is just your normal runs on a calendar of some kind. Maybe hourly, every minute, every 5 minutes, 3 times a week, whatever it might be. There's also a storage event trigger, which is the other type of main trigger. And that's basically when a file gets created or updated, and that's tied to your Azure blob storage. So if something, a file gets dropped into your Azure blob storage, it can create a trigger, which will run a pipeline to do something with that file. Then we have our global parameters. So if you want to create parameters that are available to all of your pipelines, maybe you want to store like a global server name or some kind of value somewhere that you want available to all of your pipelines, then you'd stick it here in the global parameters. Then it would be accessible there. And then the rest of these are more advanced things, security credentials. So for instance, if you want to set up a Azure Key Vault to tie into your, store your credentials into, so that they're not being stored in the data factory pipelines, then you can do that there as well. But again, that's beyond the purview of this discussion today. So that's the various things in the Manage tab. Let's pop back here to the Monitor. So as you run pipelines, whether they're kicked off by a trigger or whether you run them manually as a debug, you can see the output of the pipelines here. So there's a bit of information that it'll show you, and you can go back as much as the last 30 days worth of pipelines, and you can filter it all kinds of different ways. But you'll see what the name of the pipeline was, when it ran, when it ended, how long it took to run. In this particular case, it took 11 seconds, 10 seconds, 11 seconds. Whether the pipeline succeeded or failed, and what it was triggered by. If it's a debug session, it'll be a manual trigger. If it was scheduled by a trigger event, whether that's scheduled or a storage event, then you'll see a GUID here that represents the trigger ID. And then you'll see the run ID here. And then if any parameters were passed into the pipeline, you'll see those listed out over here as well. And then you can see that under both pipeline runs, you can do both triggered and debug sessions. Triggered runs just shows those that are run by a trigger. Change data capture is another preview feature we're skipping over for today. Then you can see the sessions by the integration runtime. So if you want to see which pipelines ran on which integration runtimes, you can do it that way. And then, of course, your debug sessions. This will show you any currently active debug sessions. So when you start a debug process, it kicks off an instance in the integration runtime, and that can run for, you can set that to run for 1, 2, or 4 hours to be available. That's basically just a way of minimizing resource usage by defining a set amount of time that the debug instance is available. And then if there are currently any active debug sessions, you'll see them here. And as you can see at the moment, there's nothing currently active. And then you have your alerts and metrics. So if you want to set off alerts, it would be an email, a Teams message, an SMS message, something that happens when, generally when a pipeline fails is when you'd want to do that, but there may be other instances where you want to set up some kind of alert, and you can create those alert rules here. So let's go back over here and create a pipeline from scratch. So under each of these sections, and you can expand those out and see things. So one of the things you can do to help you organize things is you can have subfolders. So you can put resources inside of a folder. That's a good way of just grouping things that are alike together. I wish that there would be a way to have folders at the top level. So maybe if I wanted to have all the pipelines and data sets and data flows that are tied to a specific process that you're creating and have them all together. But unfortunately, you can't do that. It's the pipelines are all together, the data sets are all together, the data flows are all together, and so forth. But you can create folders under those, and it's better organization than nothing at all, I guess. So let's go ahead and create a new pipeline. And one of the things you'll be able to do is give it a name. We'll call this Demo 2. So if you have resources that are tied to this pipeline, if you were to click here, they would be listed here. Now, obviously, since we're just creating this, there's nothing here yet. But for instance, if you have a data flow or a data set that's tied to this, that's being used by this pipeline, then you'll see that listed under related. And then, of course, anytime that you want to look at the JSON code representation of the current pipeline that you're working on, or any of the resources really, because everything is stored as a JSON file when it gets stored in the Git repo. Then you can just click on the little braces there, and it'll show you what the current version of that is. Obviously, here we haven't put anything in here, so it's pretty much empty except for the name. So let's go ahead and go through what some of the activities that are available to you are. So at the very basic, you have the move and transform. So there's two different ways. I mentioned the copy activity, which is just a simple movement of data from one place to another. And anytime you want to add an activity, you just drag it onto the screen. And then we have the data flow, which I mentioned before is the more advanced manipulation of data. And you would have to create one of those down here first before you could drag it onto there. But for each of these, so there's a few things that you'll see here. So one is, the visual representation. You can give it a name. We'll say this is copy CSV to SQL. So maybe we want to, copy a CSV file into a SQL Server database table. You can add a description. You can have a timeout. The default timeout for each activity is 12 hours, but you can set that to higher or lower. If you want to have an activity automatically retry if it fails, then you can set the number of times to have it retry. So maybe especially if you're calling data from a web API and you want to retry if maybe you're getting like a 403 error or a 500 error or something like that back from the web API. You say, okay, something's wrong at the moment. Let's try it again in 30 seconds or whatever it might be. But you can set the maximum number of retries there. And if you don't want it to retry at all, just leave it at 0. And then, of course, you can set the interval. There isn't a way really to set like a scaling interval, try in 5 seconds and then 10 seconds and then 20 seconds. Unfortunately, you can't do that here. All you can do is set the retry interval. And I should mention also as I'm going through this that the parameters that you'll see, the configuration settings rather, that you'll see down here depend on the activity. So each activity has a different set of things that you can configure with it down here. But for the copy activity, you'll have a source and a sink. So that's the source of the data, and then sink is the destination of the data. And then mapping is if you can just leave the default if the source fields and the destination fields are the same, then you don't need to worry about mapping. But say, for instance, the column headers in the CSV file are different from the column headers in the column names in the database table, then you would have to set up the schema mapping so that it tells it which piece of data goes into which destination in the sink. So that you can do that there. Once you've defined your source and your sink, you can click on import schemas and it will automatically get the schema of each of those. And then you get drop downs where you can just manipulate things together. I'll show that here in just a second, but first I'm going to just set a data set here. So I've got a flat file and a demo table. I've already set up a couple of my services or my data sets here. So we're going to set the flat file because we want to get from a CSV file. And then we've got a CSV file here in our Azure Blob storage. Let me talk before I kind of fill this in. Let me talk a little bit about data sets. So if you need to create or edit a data set, you can create a new one by clicking New. If you want to edit the data set that's already there, you can just click Open, and it'll bring you to your data set editor. So one of the things you'll see at each level really is that you can define parameters that get passed in. So whether it's a link service, whether it's a data set, whether it's a data flow, whether it's a pipeline, you can set up parameters that will be available to be passed in and to be used by that resource. In this particular case, because we're doing Azure Blob storage, I've defined the container, the folder structure, and the file name. And again, if you want to set the defined schema, you can do that, or you can just leave it here and it'll automatically try to figure out what the schema is as it's working with the data. And then here at the main level of the data set, you'll first have to define the link service that it's tied to. In this case, it's my blob storage. And again, if you wanted to edit that, then I can click on that and it can give you your settings for your blob storage here. In this particular case, I'm just using my account key and account name. As I mentioned, here if you want to, for instance, tie or store your credential information in Azure Key Vault, then you could set up that configuration here, and you would set Key Vault, and you would give it the connection information to the Key Vault and tell it which secret to get from the Key Vault. Or you can parameterize these things also. For instance, if you wanted to put your storage account name in the global parameters that I mentioned here under the Manage tab, then you could reference that here under that. I haven't defined any global parameters, but you click on this. And if there are any global parameters defined, you'll often see them here. Or if they're just parameters set up on the link service. For instance, if I were to come down here and define parameters here, say maybe for this I want to put a storage account name under this. I'll get rid of that for the moment. But if I was going to do that, then I could define that here, and then I could reference it here. So that way you can make any resource that you're working with, you can make it much more dynamic. So you don't have to create a data set for every file that you're working with. You can just have one data set that's kind of generic data set, as I've done here. Cancel that, discard my changes. See, for instance, here I'm passing into the data set the container, the folder, and the file name because I want it to be able to figure out the schema on its own, because I don't need to have a set defined schema in this particular case. So I can just use this as a generic data set to be able to use here. And then there's, for each of your data sets, of course, you've got some information here that you'll have to help configure. And, for instance, here, if you're creating a zip file or pulling it from a zip file, you can tell what type of compression it's using. If you have common delimiter or your column delimiter, you can define what that is here. There are some predefined types, but you can also state no delimiter, or you can define a custom delimiter if you wanted to. Same with the row delimiter. What defines the end of row. The default's just character return. Whoops. Default is character return, but you could change that to a line feed, or you could have your own custom row ending delimiter. You have all kinds of file encodings that are available to you. Generally, the default UTF-8 works for most files that you work with, but sometimes you have to change that. Escape character. So if you have encoded characters in the file, maybe it's backslash encoding or double quote encoding. In this particular case, because the file I'm working with, it's using double quotes for the escape character. I've got it set for double quote. And then quoted characters. So again, if you have quoted text fields, then you can have, you can define what that is in here. If the first row is a header, you can click this checkbox and it'll use that first row to define what the column headers are. So that's kind of the stuff that's available to you for like the flat file. As I mentioned, each of them, get rid of that for the moment. Each of them has its own, customizations that will be there for that, depending on what it is. If I was to create a new data set, so just to show you here, some of the things that are available to you out of the box, there's Redshift, S3, blob storage, Cosmos DB, Data Lake, MariaDB, MySQL, Postgres, Databricks, Azure SQL, Cassandra, table storage, Couchbase. You can see all these data sets or data types. You can hit FTP file systems. You can connect to your Dynamics installation. You can hit an on-prem network storage system. Got Google Cloud Storage, HTTP endpoints, HubSpot, Jira, MariaDB, all kinds of things here. Oracle that you have access to that are right out of the box. So all you have to do is set the type and then configure it, the connection information, and you're ready to go. Really, for most of these. And if there's something that you need to connect to, which isn't available to you out of the box, one of the things that you can do, and I'll show you that activity in a minute here, is an Azure function activity. So you can call an Azure function, and then you just have to write an Azure function that goes out and connects to that other data source, gets the information you want. I mean, obviously that's more effort and a bit of a pain, but it is available to you as an option if you find that one of the out of the box things isn't going to work for you. So in this particular case, because the file that I've got here, I've got a container called Star Trek and a folder called Episodes. And my file name is episode guide.csv. Okay. So that's set for my source. Let's go over here to the sink. For this, I'm going to go to my Azure SQL. And again, just to show you, for instance, the data set for this, I've got a parameter for the table name. So I've made it more generic here, and then it just says, okay, here's my database name, and I could do that as a parameter too if I wanted to connect to multiple or to different databases on the same database server. The link server or the link service represents this link service here represents the server. So if there are different databases here, I could parameterize that, and I could connect to different databases and different table names based on that. Go ahead and do that. And the table name, I don't have a table defined for this, and I'll do that. So we'll just create a table called episode guide. So for SQL, for instance, you have three different types of behaviors. You can do just a plain insert. You can do an upsert. If you set it as upsert, you'll have to, tell what the key column is that it needs to use to define whether it's an insert or an update. Or if you want to call a stored procedure and pass the data into that, you can define that there. But one of the things for SQL that's kind of nice is that you can do auto create table as a setting. And what that will do is if the table doesn't exist, so for instance, if this episode guide table doesn't exist, which it doesn't in this particular case, then it will create the table and it will look at the data as it's coming in, try to figure out what the data type is and what the field size is, and then it will create a table in the database to put that data in before it actually inserts the data. It's not really good at figuring out the data types, to be honest, from a flat file. It does obviously better if it's coming from another database, because it'll look at the field definitions for that database and create the equivalents in the new database. But for a flat file, generally just does varchar max for everything. I'll show you that here in a second. If you want to run a SQL script before, so for instance, if you're just doing like a truncate and replace, then you could do like truncate table db dot episode guide, and then it'll run. You can run an arbitrary SQL script before it does the insert. But we'll get rid of that for now. And then of course you can set the timeout and the batch size if you want to define those. Generally, it does a pretty good job of figuring that out for itself. You can set max current connections, whatever it might be. Mapping, again, we're going to let it figure out all the mappings because we're not too concerned with that. But if I wanted to, well, actually, let's go ahead and run this first before we do anything else. Settings, generally you won't have to change too much under settings. There are just some things that are available to you. And if you need to use some custom user properties, you can define those here as well, but that's beyond the scope of this discussion today. But for the moment, let's just go back here and we're going to go ahead and save that. So when you click the Save button, that is the same as doing a git commit. So every time you click Save, it will update the JSON file and push it to the Git repo and commit it, or commit it and push it to the Git repo. Sorry. If you're working in a branch, obviously it pushes it to the branch and whatnot. But every time that you do save, that's essentially the same as doing a git add, git commit, git push. And of course, you can put in your git comment here if you want. I just generally leave the defaults unless I know I'm doing something in particular. So that's been saved. So before I run this, what I want to do is just kind of take another peek at the JSON file. So now you can see here all this information that's in here now. And this just from the one activity. So we've got that copy SQL to the type of activity, if it's dependent on another activity. So we'll show you that here in a second. Then that would be defining here. Your configuration settings of various types will be here. And then some more configuration stuff here. So we've got our source information, we've got our sync information, and whatnot. So inputs and outputs, those are data sets, link services, information. So you can see that's all here in this JSON file now, and that's what gets pushed out to the Git repo. Another thing that it has is the validate. So if you click the validate button here, you'll see what it will do is do a basic series of checks on your pipeline. And really it will do, or I should say there's two different options here. So you've got validate, which basically just checks this pipeline. If you click validate all, it will go through every single resource and it will check all the resources for any validation errors. So kind of have to be careful using validate all because stuff will pop up over here if maybe you've worked on something and didn't finish it and didn't go back to it. Then you'll see the errors from those over here as well. I'll hide that for the moment. But in this case, there's no errors found. It doesn't find everything, but it does a pretty good job of finding any mistakes that you might have made. Then what we'll do is go ahead and click debug because we're going to run this manually. So what happens is it'll create an instance of your pipeline run. And you'll of course, get an ID assigned to it. And then as the pipeline runs, you'll see updates down here. Now, usually it'll refresh every 10 seconds sometimes, sometimes a little more, sometimes a little less. If you want to manually refresh it, then you can do that manually. In this particular case, it failed. So let's look at the error here. The required blob is missing. Oh, I did not have the file out there. So let me go to my blob storage. Okay, so I just checked my blob storage. It is out there, but I spelled it wrong here. So in my source, there's not an underscore in there. So save that. And one of the things you'll notice is anytime you come in here and edit, you can still see the results from the last run. So if I were to click out here, just in the empty space, that brings you up basically to the pipeline level. If you click on the activity, what's down here is the activity that you've highlighted. If you click out here, you can see stuff at the pipeline level. And even if I were to close this and then reopen it, you can still see the results from the last debug run. And that's a pretty nice feature that's in here, because you can kind of pick up where you left off. So that has been fixed. Let me run debug again. I'll give that just a moment to run. It should only take about 5 or 10 seconds. Go ahead and click manual refresh, so you can see it succeeded this time. So, obviously there's only one step here, but if I were to have multiple steps, then you'd see them out here one after the other. And it basically, the oldest is at the bottom, the newest is at the top when you look at this list that shows up here. So for each step, you can see in the results, you can see the inputs for that activity. It'll show you some information there about what kind of went into the activity. And by inputs, it doesn't mean like the data that's going in there. It's referring to the activity information. So you can see here, I've got my sink defined. I've got my source defined. It just gives you some information about that stuff. Then you have outputs, which will give you information about what the activity did. So in this particular case, it read this much data, it wrote that much data to the table, it read one file. Peak connections 3 to there. So it was 944 rows that were read, 944 rows that were written, and that took 8 seconds. The data throughput did not have any errors that came back. And there's just information about billing. So obviously, Azure resources are mostly consumption based. So, you pay for what you use, and you can see how much was billed for this run. You can see the various things that were involved in that. This information about the blob storage, and so on and so forth. So, there's a lot of information that's there for you to look at. And I'll leave that as an exercise for you. And then for a lot of activities, you also might see a little pair of glasses there. That gives you some information, kind of more visually, about what was done. So say information went from blob storage to SQL database. It read in 1.391 megabytes. It wrote out 2.722 megabytes, one file, and so on and so forth. So is that. So let's take a look at the SQL. And you can see my demo database here. There weren't any tables. I'll refresh. So now you can see it's created this episode guide table. And I mentioned before, most of the time, if it's coming from a flat file, you're just going to get varchar max on all the fields. And then you can just see the data that was written out here. And there are 944 rows. So let's add a little bit to our pipeline here. So let's say we want to do, let's first, before we add some more, let's look at some of the other activities that are available to you. So Azure Synapse, Azure Data Explorer, those are kind of more advanced things if you're working with Synapse, or the Data Explorer. You have those activities there. I mentioned Azure Functions here, so you can call out to an Azure function if you want to do some custom manipulation of data, or if you need to connect to something that isn't supported out of the box, you can write an Azure function. And whatever you can do with Azure Functions, that's what you have access to through this. You call it to the function, you get the results back, and then you can use that as an input. You can create custom batch services. If you're working with Databricks or Data Lake, those activities are available to you as well. One of the ones that you'll use the most are stuff here under general. So one of the things you can do is you can define variables for your pipeline. So if you want to create a variable to keep track of something, and you can manipulate it, you can add to it using the various set variable, append variable things. Delete. So if you want to delete a file, so let's say if we wanted to, after we've imported our file, we want to delete the source file, then we could just drag a delete activity out here, and then one of the things that after each activity there are 4 options. So there's on success, which is the default. So let's say as long as our copy activity was successful, we want to delete the file, then we would just drag from the checkbox or to the delete activity. And then we'd go into our delete activity and we'd say, okay, we want to delete our flat file, and we would put in the parameters and whatnot there. If you want to have a separate pathway for, if the process fails, then you could drag it from on fail. If you want on completion, so regardless of whether it succeeded or failed, you could have another pathway here. And you can create multiple pathways too, and I'll show you that here. Or on skip, so if this was skipped, then you could define the next step to take there. So let's say maybe we want to do a lookup and a parallel pathway, and just go on and do other things. You can add and add to it. There is a defined number of activities, a maximum number of activities that you can have in a pipeline. And currently the maximum number of activities you can have is 40. I've heard that they're working on perhaps expanding that to a higher number at some point soon. But at the moment, the maximum number of activities you can have is 40. But one of the things you can do is you can call another pipeline. So, if you're if you're going to need more than 40 activities, you can just create sub-pipelines and just have a parent pipeline called multiple sub-pipelines. That's very common. Also, creating pipelines to call into is very common if you have common code, things you want to refactor out. So maybe you have 10 different pipelines that all need to do something common at some point. You would create that common pipeline, and those 10 different pipelines would call into that one pipeline to perform those other steps. So it's a very, very common thing to use the execute pipeline activity. So maybe after we delete, we want to do something else here, call another pipeline, do something like that. You can import SSIS packages and call those. You can call SSIS packages here. So maybe if I want to do that, then you can say, okay, I'm connecting to an SSIS package somewhere and want to execute that. As part of that, you can do that. If you want to force a failure of a pipeline, so maybe there is some set of circumstances that might occur in your pipeline that you don't want to, or wouldn't normally cause the pipeline to fail, but you want to force it to fail, then you can use the fail activity. Get metadata is commonly used for instance, getting a list of files in a folder in blob storage, perhaps, or in network storage, or maybe getting some information about a particular file. Things like that. Get metadata is what you would use for that. Lookup is one thing where if you want to get a piece of data from a previous activity, so maybe I use get metadata to get a list of files, and then from the folder, and then use a lookup to filter that list of files into a smaller list of some sort, or maybe just get maybe there's 20 files in there, but I want to get just the Excel files. You would use lookup for that kind of thing. Store procedure and script, if you just want to call it just SQL information, call SQL store procedure, execute arbitrary SQL script. I talked about variables. You can do validation activity, just check if something is correctly validated and in place before you run things. Then there's, if you want to call out to external web endpoints. You've got web and webhook. So the difference between these two is that web is fire and forget. So maybe if you want to just shoot information out to maybe like a logging application or something like that, you would use web. Webhook instead, as an alternative, it waits for a response. So if you're calling an API, you would use webhook. So you're calling out there, you are getting a set of data back. And if you want to force a wait, you would use the wait activities. Maybe I want to wait for an hour for something else to happen somewhere else. Might do that. And then the other set of activities here I want to show you is the iteration conditionals. So obviously, your standard filter. Actually, filter, I mentioned that example here previous with the lookup where I get the list of Excel files. I would actually use filter for getting the list of Excel files. Lookup would be if I want to get information about a specific file. So maybe I get my list of Excel files, and then I want to get specific details about the first file on the list. Then I would use the lookup for that. Sorry. I frequently get those two backwards. I apologize for that. And then, of course, the loop stuff. So, for each, if else, switches, do until kind of things. So those are the highlights of the activities that are available to you. So you can see there's a bunch of stuff that you can make use of. Obviously, being about moving data back and forth, the two that you're going to use the most are data, or copy data and data flows. And let's just pop over here to data flow. We'll just create an example here just so you can see the kinds of things you can do in a data flow. So again, the same thing, you can give it a name. You can add the source. In this particular case, we're going to just pull in data from our flat file. And you can set up the information about that. One of the cool things about data flows is that you can have different kinds of data sources. So I've got my flat file here. Maybe I want to add a second source for my SQL table. And then I want to join those two together. So, we would have like a join here. I would say the left stream is my source 1. The right stream would be my source 2. So you can see that you can join those two together, and you can do different kinds of joins like you would do in SQL. And then, you just define what the conditions are. So maybe, I want to join on an ID and of some sort, or however it is that you want to join the data together. Then you can do that, and it combines that information together the same way that you would do a SQL join between two tables. But in this case, you could do it between a flat file and a table, or two flat files, or whatever your different data sources might be. You can use a data flow to join that information together. You can manipulate it. There's all kinds of things that you can do with data flows. So you can split data apart. So maybe you want to process a file and split it out into 10 other files based on like company ID or something like that. Then you could do that as well. And then you could do pivot tables. You can do all kinds of things. Data formatting. You can add rows. You can add calculated rows. You can piece together different things from various data sources and just bring them all together. And then, of course, your very last step has to be your sync. So where is it writing to? And you can have multiple syncs. So like I say, if you want to have it write out to 10 different files based on company ID or something like that, then you can set that up in your data flow. There we go. So that's a kind of a high-level view of data flows. But one of the fantastic things that you can do, it's sort of like a derived column here, is that they have this wonderful thing called expression builder. So you can do all kinds of manipulation of data, and there are so many different functions that are available for you to use to manipulate and work with the data, to join the data together, create calculated fields like I mentioned, all kinds of different stuff that you can do. And that's the true power of ETL systems, is being able to manipulate that data in ways that are of benefit to you. Whether it be you need to take the data from 20 different systems, merge them all together into a single record in a data warehouse, and organize that data in a particular way. Pulling in just the pieces of data that you need from each one, or calculating, okay, maybe if you're doing like a a customer marketing system, and you're pulling in all this information about your customers. What have they bought? What have they looked at on your website? What email interactions have they had? Have there been complaints? Have they done returns? Whatever it might be, all kinds of different things that you can look at. Combine that all together, and then use this information to kind of calculate. Okay, how do we want to market to them going forward for the next 3 months, 6 months, or just the next campaign, whatever it might be. Then you can build that kind of stuff in your ETL system. All right, so that's a data flow. And then just kind of come back over here to look at this. So I mentioned like the depends on here. I've put in a bunch of new activities. If I come down to one of the additional activities, so here's like an example. It depends on. So I added that SSIS package. You can see it depends on lookup 1 being succeeded, that kind of stuff. So that's how it's represented in JSON. So you can see my SSIS package depends on lookup 1 having succeeded, that kind of thing. All right, so there we have it. That's kind of a high-level overview of Data Factory and ETLs in general. All right, so if you have any questions or want to learn any more, you can check out my my blog at bearblake.dev, or you can connect with me on Twitter or LinkedIn, or pretty much any other place where I kind of hang out. I do have a few YouTube videos, including this one, will be posted out there. And I'm continuing to add to that as the weeks go by and months go by. And I thank you for your time, and I hope this was of use to you.
9:18. Your efficiency is duly noted. From now on, all time estimates will be reduced by 50%.
You gotta be kidding me.